everybody. So today is your first day of chemistry lecture. And so if you have not already, pause this video so that you can go and you can print out these PowerPoint slides. So I have on my Ultimate Say all of the PowerPoint slides for every chapter. And so if we're on that chapter, you want to print it out because what you'll see is I've got blanks and stuff for you to fill in. If you can also tell, we are in one of the classrooms at Ultimate Say. And so it's going to look just like if you were sitting in class right now watching me teach lecture. That's what it's going to be like. All right, so let's start. So our first chapter is chapter E. It's called Essentials, Units, Measurement, and Problem Solving. So this is just kind of a little bit of an intro to kind of how we do math and how we think about science and chemistry specifically. So some of this might be a review or something you've already heard before if you've taken really good science classes before, but that doesn't mean that you can just kind of be like, oh, I already know this, and take it easy. Okay, so make sure you keep staying on top of things and not getting too lackadaisy. All right, so you're in chemistry, so you might say, well, what is chemistry? We have biology, we have chemistry, we have physics, we have all of these different science classes. So what makes chemistry chemistry? So if you look here, it says chemistry is the science that seeks to understand the behavior of matter by studying the behavior of atoms and molecules. So this is what defines chemistry as being different from the other sciences. So mostly we're going to be looking at atoms and molecules. Now, whenever I talk about chemistry and I try to kind of help you think about how to kind of look at chemistry and how to approach chemistry, I want you to think of chemistry in two ways. It is a science class, but I also want you to think about it as like a foreign language class. You might be thinking, what? How is it a foreign language class? And it's also, and let me make it three ways, also kind of like a math class. So let's start with the foreign language. So a lot of people think, well, why is it a foreign language? Well, in chemistry specifically, you're going to hear and use a lot of words that you've never used before. So there's going to be a lot of vocabulary that you have to learn. Now, it's still going to be English, but some of these words have Latin roots, so they kind of sound a little funny, okay? So you have to learn all the vocabulary words. Second, there's a lot of math. So chemistry is kind of like the hybrid between biology and physics. So biology is kind of on this side of the spectrum. It's got a lot of vocabulary, and the science part of it is stuff that you're used to. They'll study animals, they'll study the human body, they'll study plants, and that's stuff that kind of your whole life you've kind of seen or interacted with. You've seen your body, you've interacted with your body, you've seen different animals and played with them, and you've been out in nature and seen different trees and plants and all that. So a lot of it's not new. So with biology, you've kind of been exposed to it. Also with biology, there's very little math. Then on the far other end of the spectrum is physics. So physics, it's going to deal with things that you've done in sense of like motion, you've moved, you know that things roll down hills, those kind of things. You might not have gotten to all the depth of like electricity and those topics, but you've heard about it a little bit. But physics uses a lot of math, but they also use things you've seen mostly. So chemistry is in the middle, okay? Some of it you've seen. You've heard of solids, you've heard liquids, those kind of things. And you might have heard of an atom or a molecule, but a lot of it is going to be new to you. There's going to be a lot of new vocabulary that you're going to have to learn. But we have also math. So we have more math than biology, and sometimes we have about the same as physics or a little bit less math than physics. So we're kind of in the middle. So that's where we fit. So chemistry is kind of in between the spectrum of biology and physics, and we have a lot of math, we have vocabulary, but we also have, which is the hardest, things that you haven't really interacted with. Last time I've checked, you don't see atoms and molecules on a day-to-day basis. You don't go outside and see an atom or a molecule per se, okay? You might see water that's made out of molecules, but you don't see the molecules themselves. So that's where chemistry is very different, because we're going to talk about things that you haven't been able to interact with or think about in that small size. You're used to seeing bigger macro things like, dogs and cats and those kind of things. All right, so that's chemistry. We're going to talk about specifically what things are made out of. So when we're talking about atoms and molecules, it's what makes up everything that we're going to study. Atoms and molecules make up us. It makes up the desks. It makes up the air. It makes up everything. We're going to see how when atoms and molecules change, how does that affect the things in the world? How does that cause a reaction to happen and create new things or change the thing that we are talking about, like with rusting? And then we're also going to talk about the fundamental laws. So there's going to be laws that are going to govern why atoms and molecules behave the way they do so that we can make predictions as to what to expect. Okay, so let's talk about some standard units. Standard units are called SI units. So SI just stands for System International or International System. And so you might want to know, well, why do we need international units? So I might be walking around and I might ask you, what's the temperature outside? And you might say, oh, it's like 100. And I might go, it's 100? And you're like, yeah, it's 100 degrees outside. And I'm thinking, whoa, how is it possible that it's 100 degrees outside? Like, that's gotta be crazy. How is it that hot outside? Well, here's the difference. If you're in the United States, 100 degrees to you is in Fahrenheit. But if you're talking to somebody staying in Europe, where I'm from, I was born in Germany, we think in Celsius. So 100 degrees in Celsius is very, very hot. But 100 degrees in Fahrenheit, not so bad, okay? So we need to kind of talk about what scale. So whenever we're talking about things in science, different numbers, different measurements, we want to make sure that we're on the same page. Also the same thing with weight. You might say, oh, how much do you weigh? And you might say, well, 100. Well, they might be going, okay, is that 100 pounds or is that 100 kilograms? Okay, so you need to make sure that you're on the same page. Whenever you talk about numbers, if you're reporting numbers, or if you're writing like a scientific journal or something like that, you always want to be accurate and on the same page. So for science, for chemistry, we have the System International, which means that whenever we report numbers in a scientific research journal, or if we're talking about it at a conference or something like that, we want to be on the same page with what the units are. So these are going to be the units that are the standard units. So let's walk through them. So the first one is length. So the standard unit for length is a meter. And the symbol is going to be a lowercase m. Next is mass. The unit for mass isn't the pound, because that's what you're used to here in the United States. It's actually a kilogram. I gave you a hint about that earlier when I referenced it. And the symbol for kilogram is a baby K and a baby G. The next is time. And so here we're not talking about, because we're going to talk about how the molecules and the atoms move very quickly. So we're not going to be talking about necessarily long periods of time. So we need short periods of time to be more accurate and precise. And so our time here is going to be in units of second. And the symbol is a lowercase s. Now sometimes you might see them write like SEC period. And that's mainly because depending on if you're handwriting it or not, a little s can look like a 5 for some people. So sometimes people will write SEC dot for a short notation for second, just to make sure that you understand what they're writing. Next is temperature. Now you might think, okay, Fahrenheit, or you might think, okay, well, she talked about Celsius earlier, maybe it's Celsius. But they actually have a different scale. So to not kind of favor one or another, Americans versus Europeans, what they use is a different scale, and that's the Kelvin scale. And we'll talk about that scale in a little bit. And it's a capital K. It's a capital K because it's based off of the guy, Lord Kelvin, and so since this is a name of a person, it's a capital K. All right, next is volume. Volume is going to be represented, you can kind of think about if you go to the store and you're getting a soda, you usually get a soda if you're trying to get a big bottle of soda, you would get like a 2 liter. And so the volume here would be a liter. And the symbol is a capital L. And then next is energy. This is the last one. And that unit is going to be the joule. You may or may not have heard of this unit before. And it also is a capital J. And it's a capital J because this guy is also a person. So, because this is a dude, then he gets a capital J. Now this is a capital L because sometimes the L looks like a 1, so they just want to distinguish it from the numbers. Okay, so you need to know all these SI units. There's a table in your book that has all these units, and you do not have to know the luminous intensity unit. We don't really use that in chemistry, but these are the ones that you need to know. Okay, so we're going to stop here, and on the next video, we're going to start talking about conversions and conversion factors.